Okay, so today, like I said, we're going to talk a little bit about um, comparing what we call inline recovery to instant recovery. We're going to give a quick slide overview of ioGuardian, and then Paul's going to go right into the demo. He's got some things orchestrated. It's always a little terrifying when I ask one of the guys to make stuff break on purpose. It's not normally a best practice. Just as Paul said, he's been with the company since the inception. I'm going on 2 years now. Seems like only yesterday. Company's been around for quite a while. We started in the virtual SAN space, so we technically had the first vSAN on the market. We then later integrated that into a hypervisor technology, and then also added in software-defined networking capability. Our primary focus today, and actually has been for quite some time now, is being an alternative to VMware. And I think what you'll see in this presentation, it's more than just can you be less expensive. Frankly, VMware has, or Broadcom has, made that part a little easier than it used to be. It's can we deliver some unique capabilities that don't exist in some of the other products, and I think this product is a really good example of that. So let's jump right into the comparison. Um, the Well, before I do that, I want to just kind of talk about data availability as a whole. We've got several capabilities that I think are really important here. First of all, the entire environment is highly available. So if a node fails, if it goes into maintenance mode, we'll live migrate VMs over to surviving nodes or hosts. If there's a sudden failure, we'll restart those VMs. So you've got complete HA built into the product. IO clone, which is our snapshotting capability. So it's a little unique compared to like the traditional snapshot technology in that these are independent. And so they protect, they can do more. You can keep more of them. You can use them in, as if you will, almost golden masters. The third thing is our replication capability. So built in the product, we'll probably talk about a couple times today, is our global inline deduplication. We can it's that global aspect becomes important when we start talking about replication, because we can replicate between multiple sites to one site, and the only thing that goes across the wire is unique data. So that saves a lot in bandwidth. And then finally, the thing that as we get into larger and larger enterprises started to come up was, okay, well, how do you recover from multiple failures? And that's exactly what ioGuardian addresses. And so let's talk about that a little bit. So the backup process, I'll label it as near continuous. It's certainly faster than what most people do backups. Paul, there's a range here depending on how many, at what level of granularity you're doing. And we leverage our snapshots to create this backup on the ioGuardian server. There's a range here that you can hit, and I think it's important to know that we can reduce this number pretty low, but there's things that we'll want to think about from a configuration standpoint as we adjust this time frame up or down, right? Can you give some background on what that looks like?
Yeah, so today the way our replication works is that it is schedule based. We do our replication of what we call our cloud snapshots. So a cloud snapshot is a snapshot of the entire environment, meaning every virtual machine, network config, IP addresses, everything that exists within the Verge operating system is contained in that snapshot. So the replication is happening at that snapshot level. For smaller HCI environments, that are syncing once a day, the overhead for synchronization of that is pretty minimal. But once you start to get into larger scale, lots of metadata, lots of virtual machines, large virtual machines, we'll push customers towards more of like dedicated storage nodes and dedicated controllers. And what that enables you to do is really speed up the process of synchronizing this metadata and deduplicated data across to a backup DR/ioGuardian server, so that you can get those, your SLA down. In the demo that I'm going to show, it is a small data set, but I currently have it replicating every 5 minutes. But mainly, there's not a lot going on, but once you have these larger environments, we'll push customers towards dedicating specific servers for this use case to enable them to have the least amount of downtime and fastest replication.
Cool. All right, and then I think the other big thing is what we call inline recovery, and we're going to do a comparison because I think if you will, the former state of the art was instant recovery, and we'll do a little bit of a comparison between that. Paul, I always say there's 3 moments in my IT career where I said wow, and not wow exclamation point, just wow. The first was the first time I saw a vMotion happen. I thought, well, that's pretty cool. And then the second time was when I saw a instant recovery where they recovered the VM on the backup appliance. And the third time was when our CTO, Greg, showed me how inline recovery. I almost got to an exclamation point on the inline recovery too. So and I know you're going to walk people through that process visually through the demo, but give an idea, like, so let's say we have a multiple failure, just at a high level, what's the process of saying, okay, boom, these VMs are now ready to come back up to life?
Yeah, so first I'll walk you through, traditional, you're powering a server off for maintenance. In that case, if that server that you're taking down was a part of our vSAN, meaning data was being replicated there, we are mirroring data between servers. So that server goes down. The way our vSAN handles that is, let's check to see if, a block of data is requested. Let's check to see if it exists on the primary server. That the algorithm, that follows this step, that part's going to fail. And then it's going to immediately check the backup copy of that data, which would be on a separate physical host on a different drive, all real time while the virtual machine is waiting for the IO, whether it's a read or a write. So that's the standard maintenance. Data still lives there. Now, in the event of that secondary server, if that fails, hard drive dies, power supply dies, whatever that may be, that logic breaks down. So primary copy is gone, redundant copy is gone. So the way our vSAN handles that is, at the tier of storage, we broadcast out to every vSAN node in the entire environment, no matter how large or small. And we say, does anybody have this block of data, whether that's on their cache or whether that's on a separate tier of storage or any drive? It doesn't matter. We will broadcast that out. Now, if that fails for whatever reason, this is where ioGuardian kicks in. ioGuardian, which we also refer to as our repair server as well, will connect up to any location that you are currently synchronizing to real time and request that block of data. So the more frequently you're replicating, the more likely you are to be able to have workloads continue to run without any downtime at all. The only thing would be is the penalty of latency, depending on where these systems are installed. They can be anywhere in the world. If it's local, that latency penalty is going to be a lot lower than, say, across the country.
Right, and I think it's also important to note that the primary production VergeOS environment could be all flash, and you could have hard drives in the ioGuardian server, obviously with the asterisk that a hard drive is slower than a flash drive. Mm-hmm. But that would be an acceptable configuration also, correct?
Absolutely. That's
cool.
What majority of our customers do for this purpose. It's a last ditch effort. Data is gone locally. Let's try to find it somewhere else.
Okay. And there's a story, I know we can't yet mention the customer name, but there's a story I want you to tell. Although I might tell it, I think I've embellished it to be a little bit more exciting, but let's go with the real version, and we'll tell that here in just a second. So let's just kind of do a comparison. My background is such that I kind of knew the instant recovery space pretty well. And so that's the first thing I sort of equated things to. And so what I have on the left side here is sort of the capability or feature. And so one of the things, obviously, and sometimes these two words are used incorrectly, but recovery time objective and recovery point objective, right? So the time is, the way I describe RTO is how long does it take before people can get back to where they were? And Paul, it sounded to me like it could be as little as no time. Is that right?
Yep. It just depends on the scenario.
Yep. And then in instant recovery, whether it be from, well, I don't want to name any backup vendors, but we all know who we're talking about. You are going to have some downtime. That VM likely is going to crash. You're going to need to restart it on the backup appliance, and your RTO then is also affected by your RPO, because most people, and that kind of gets into that second line there, most people are not doing backups every 30 minutes or anything close to that, right? They're doing typically aggressive backup schedules that I've seen are 4 to 8 hours. In most cases, we're still sort of on the once a night type of situation. Now, in our world, that changes a little bit, because as you kind of just elaborated, you could have a much more aggressive snapshot schedule than what people normally have as a backup schedule, right?
Absolutely. Yeah.
Yeah. Now, from the data recovery process itself, I think we just kind of talked about that, and I know you're going to show it, so let's skip that. But on the instant recovery side, again, the VM, not likely, is absolutely going to, and the scenario I'm talking about here is you have a multiple drive failure, right? So a double drive failure on a RAID array or something of that nature. That VM is definitely crashing. It's a manual process to restart the thing on the backup appliance. And obviously, if there's a crash, you've got potential. If it was something that was busy, you might corrupt data or anything like that. And certainly, I think this is the thing that most people forget on instant recovery is you're running on a backup appliance. It wasn't necessarily designed to host VMs, right? And so you'll probably see a performance loss. Now, as Paul mentioned, you could see some degradation of performance as we access data from the ioGuardian server. But Paul, correct me if I'm wrong, the VM itself continues to execute in the primary environment, right? Production environment.
Yep.
So
the machine will stay there, and then use the connection to ioGuardian to continue functioning.
Yep. Okay, cool. And then from an intervention standpoint, it's basically minimal versus a lot, the opposite of minimal. So it's a pretty seamless thing. And again, we're going to show you to you in real time here in just a second. So we talked a little bit about performance already. I also want to talk about storage efficiency, because important to note, right, Paul, that the ioGuardian server, it is running VergeOS, right?
Mm-hmm.
And so it therefore gets all the capabilities of VergeOS. One of those things would be global deduplication. So that means we get that same benefit as far as data transfer and all those sort of things, right?
All the same benefits. It is 100% a copy of our operating system and has all the same capabilities.
Exactly. And so in a environment like that would not be of that situation, in frankly almost every environment that I've ever seen, let's say you've got a storage array, or let's say you're running vSAN with their deduplication activated, and then you're going to back up either using backup software built-in deduplication or using a backup appliances deduplication. That data has to re-inflate on transfer, and then has to be re-deduplicated once it lands, right? And so you've got this, you kind of got this double deduplication going on, and in between you've got to undeduplicate it to be able to get that done effectively. So it's a bit of a problem. From a cost perspective, the amazing thing I think to me is that everything we're going to show you today is built into the core product. We license by the physical server, so we don't charge by cores or processors or RAM or any of that stuff. And so the only extra cost here is just the cost of a physical server. Side note here, Paul, let's say you've got, compared to your production servers, does this need to have the same, I would assume capacity is the big thing, the ability to hold a lot of capacity, more so than processing power. Can I get away with an older unit as my ioGuardian server?
Absolutely. Yeah. If you're not going to run workloads, why waste the money?
Okay. So we can use hard drives, we can run, and I think but there's you can make an argument the other way, and we actually probably wouldn't argue with the customer. We wouldn't say, if you said, hey, actually I want to put flash on there, I want it to have some decent performance, we'd be okay with that too. So whatever makes sense for both your budget and your needs as far as getting things back up and running quickly. Obviously, from a cost perspective, on the backup side, you're paying for the appliance, you're paying for software licensing, you're paying for all that sort of stuff. And then the final thing, which I forget if you said you're going to be able to show this or not, Paul, so I'm going to pretend you are not, and maybe you'll surprise us. But if you, let's say you did have a double drive failure, and you replace those drives with ioGuardian, what happens, Paul?
Yeah, once you replace the drives, if that data does not exist locally, it will use that same ioGuardian server to rebuild the drive itself.
Yeah, so lots of benefits there. I don't have to go to my recovery software. I don't have to consume a lot of production processing power doing stuff. Where in the backup server environment, that's essentially you've got to restore the entire volume. So that's a bit of a challenge, to say the least. All right, so that's it. I fulfilled my promise. I kept it to just a couple of slides. I'm gonna turn things over to you, Paul, and let you wow us with the demonstration that you've got set up.
Okay.
All right.
Excuse me. So to start here, I just want to show you how this environment is set up, just so you can have a little understanding. I'm actually running Verge operating system in virtual machines. It's much easier than me trying to figure out how to pull physical drives from servers and kill power on them. So I have a lab over here that has 4 nodes. Each node is running the Verge operating system, and this is the system, as you see the 4 nodes here, that's running it. I have 2 tiers of storage. So tier 0, if you're not familiar, tier 0 is what our vSAN uses for metadata, information about deduplication, important things about the file system itself. And then I have tier 3. This is where all the virtual machines are going to live. This is solid state. You'll see all 4 servers here actually have data on this tier of storage. So I have 4 nodes. And then the way our vSAN is working is we are mirroring data between physical servers. Going back to here, in this environment, I currently have 4 virtual machines running. And what I'm going to simulate here is going through planned maintenance. We're going to take a node offline for the purpose of, let's just say we're replacing drives, or you don't need to do that with it offline, but you're swapping out bad sticks of memory or power supply, whatever that may be. We're going to put each one of this node into what we call maintenance mode. What maintenance mode does is it evacuates workloads from that server. Once it's done, we are then safe to power this server off. So now that we are going to power this off, we'll wait for that to shut down. And then in the meantime, you'll notice over here right now, the vSAN is still green. That means that all servers are still online. Once that 3rd server is fully powered off, which it is now, you'll see now the vSAN is flagged as non-redundant. And what that means is there is data missing locally, but we still have a backup copy. So if I go over here and look at the virtual machines, you'll see now that that is powered off, we have this virtual machine stopped. Now everything is still running locally at this point. ioGuardian has not kicked in yet, mainly because there is a backup copy of the data. Let's say if the data was supposed to be written to node 3 or read from node 3, that server is now offline. So it's going to go to, let's just say, node 4 to get that copy of data real time while the virtual machines are still running. So now somebody's in the data center, they accidentally bump a power cord, yank a power cord. So let's go ahead and kill power to this server.
Oh, now, Paul, you did that not gracefully, right? I mean, you're just
right.
Essentially, okay, yeah.
Yeah, this is, we're simulating someone pulled a power cord or, yanked all the network cables out of it. And now at this point, that backup copy of the data will no longer exist. So this is where ioGuardian is going to kick in, because the primary and the backup copy of the data are no longer local. So, so what ioGuardian is going to do, a virtual machine will request a block of data that doesn't exist locally. It's now going to connect up to that server, the remote ioGuardian server, and serve that data back up real time to the guest operating system itself.
Now, Paul, just before you do that real quick, some of the data is local. It's just that not all the data is local, right? Because the way we spread data, we would have spread it across all 4 nodes.
Yeah,
correct?
it's not 100% of the data is,
right.
local.
Gotcha.
In this case, 4 nodes, it's 50% of the data is going to be missing.
Gotcha.
So now you can see that there's actually errors popping up in this environment. These error walking tier 3 errors, what that's basically saying is, I don't have enough information to actually guarantee that I'm redundant. So this is actually the virtual machine right here. That is node 1. So you'll see that, there are errors actually occurring. Now, if I were to go into, nope, not this one. Hold on. Let me get back to this page. Filter on that. Now, if I go into one of these virtual machines here, let's pick this one right here. And I console into here. If I just start poking around in here, you'll see that I'm still able to walk this file system. I'm able to look for data. I can read from the drives. I can write to the drives as well. The writing is going to happen at a performance penalty because we need to ensure that those nodes are still offline, and then we actually will commit data locally on this server. So you'll see right here, now it says block was missing from local cluster. Let me scroll up here. And then it's retrieved from the remote server ioGuardian sync. So now that this data is no longer local at all, we're having to go over the wire, pull that data back. And if I go into, let's just exit out of that. If I go and look at this sites section, you'll see this is that ioGuardian remote site. So this is my location right here. This is where ioGuardian lives, right over here in the purple. If I click on here, you'll see we're trying to replicate to it right now. And also on top of that, we have the ioGuardian server configured right here. So this is where you actually see the configuration of these items. So we're actively connecting up to this location right here to real-time pull that data. Now, while that's going on, let's go ahead and be very friendly. Power these virtual machines back on. And we'll let those come back online, and we will notice in this environment, once it's done, that the vSAN will fully repair itself and bring itself fully redundant again. One other thing to note, if I go and look at my outgoing sync right here, I'm currently replicating a snapshot profile right here that is taking a cloud snapshot once every 5 minutes. So if I go and look at my cloud snapshots, you'll see I have a snapshot being taken every 5 minutes. It's pushing it off site and holding on to it for an hour. So that's my data protection. I can guarantee that every 5 minutes I have a copy of that data at that remote location. So now let's wait for.
And Paul, remind the folks from the snapshot perspective, we can be granular at what we call the cloud is essentially the entire instance or production copy. And then how much can I go lower than just the cloud if I want to, as far as granularity goes on snapshots?
Well, the cloud snapshot profile, you can configure to be whatever you want.
Okay.
So we do have a default policy, excuse me, that takes a snapshot every hour. And then there's one that gets taken at midnight and it's held onto for a little bit longer. And then there's a midnight that gets held onto for 3 days. But you can very easily, and I'll show you where. So yeah, you'll see these nodes are back online. vSAN is fully green. This node's back in maintenance mode, disable maintenance mode. And now we have fully real-time recovered from this without a single virtual machine having an issue with these these vSAN scale out nodes from being down.
And if I got what you just showed, you did more than just fail 2 drives, right? You essentially failed 2
I
entire
failed 2
servers.
entire servers, yes.
Yeah.
Which failing a drive is one thing. Failing a server is you lose every single resource that was
Yeah.
serving.
And then on the where I was going on the snapshots, we can snapshot at the cloud, at the tenant, and at the virtual machine. Is that right?
Yep, that is correct. Cloud
Yeah.
encapsulates all of that though. So out of the box, you already
Right.
have a snapshot of literally everything. And if you
Got
need
it.
to change those, your retention policy, you can go to the cloud snapshots policy here and see what its default configuration is. And if you need to change, to hold on to these for longer or take them more frequently, you can do that here.
Got it. Okay. Good. So got a couple of questions coming in. Does the ioGuardian server need to be dedicated just for this task?
Nope. This could be another production workload, another production cluster that you're using, say for DR. You have a data center in Seattle, you have a data center in Florida. They can replicate to each other for DR purposes, as well as become an ioGuardian server as well.
Okay. And then another question, actually a really good one. How are you backing up the ioGuardian server? What happens if it blows up? So I think the first thing is understand that this is a multiple tiers of protection, right? We've got the mirroring that Paul mentioned. We've got the snapshots on top of that. We've got ioGuardian. And then if I remember correctly, you can do snapshots within ioGuardian as well, right?
Yep. And
Yeah.
you can replicate those snapshots elsewhere. It's up to however you want to configure this. The production cluster could replicate to 3 different ioGuardian servers. Or you can string them along. The only problem with stringing them along is if data is missing somewhere in the middle, this first primary production needs to have a connection to that redundant ioGuardian server as well.
Gotcha. So let's say you're setting up. I know we get a lot of folks that do use us, use the DR capabilities of our product with IO Replicate. Could that DR site be also? Could I also run ioGuardian there as well? Or would you
Anywhere
want
that
it in
runs
both
Verge,
places?
any system that runs VergeOS has the ability to become an ioGuardian server, as well as run workloads. It's up to that single license that you buy for VergeOS encapsulates. You can make it be whatever you want. So there actually
Great.
was a question on here. Does ioGuardian require a separate license? It requires our standard or backup DR license.
Right. Yeah. So it basically runs, as we said, it runs VergeOS. It's just
It's a feature.
less expensive license. Yeah.
Yep.
Yeah.
Yeah.
So
if its
very
sole purpose
affordable.
is to be ioGuardian, it can be
Yeah.
a cheaper license.
Yeah. We got a couple of people typing questions in while we're waiting for them to type those in. Go ahead and tell the story that you told me about the customer who had somebody go into their data center who wasn't supposed to be there, basically.
Yeah. So we had a customer that was replicating their environment, their production environment in the data center to another data center in a different state. They had configured ioGuardian ahead of time. So a tech went into the data center to swap out drives. They needed to change the capacity of their solid states. So he went into the user interface. He closed all of the drives on one of the servers. Then he went to the chassis, started pulling out the drives, realized that he pulled the drives out of the wrong server. So then he pulled the drives from the one where he took them offline and essentially created this double failure that I just demonstrated where data was missing. And then of course, what else happened? He didn't know which drive went into which chassis. So they had to figure out during, this brief panic moment of where do I plug these back in? What's going to happen to my workloads? So they went into the user interface and basically, to their amazement, things were still running. Because they had this repair server / ioGuardian configured and they were replicating offsite, they were then able to leave these workloads running at the penalty of latency to the remote environment. Now they have time to figure out, where do these drives go? Which one was this? This goes back into the first server. And then once they got everything back up and plugged back in, the vSAN detected that those drives were ungracefully shut down. So as soon as they plugged it into the right server, it automatically reattached it. And then the vSAN rebuilt itself during that moment of panic that they had.
Yeah, it's a great story. So the other question is, can I just have certain workloads go to the ioGuardian server instead of, in your example, with I guess the whole cloud?
So the way that we replicate is at the cloud snapshot. So the answer is maybe. It depends, because if a tenant is doing their own replication, then yes, of course, that ioGuardian server is going to protect them from a subset of their data. But if you replicate at the top level, the root tenant, then what's going to happen is everything is included in that synchronization.
Would there be any advantage to just replicating at the tenant level?
Yeah, there can be. It just depends on your use case, depending on what that tenant's purpose is. Maybe, you're an MSP and you have a customer and they don't want to pay for long-term storage, but they do want to protect themselves for 7 days. But then you have another customer that needs to hold on to their snapshots for 7 years. That would be a good use case there, to have different retention policies per tenant, so that they can replicate individually. And
Okay, so you could say the tenants that wanted that 7-year retention, those go to the ioGuardian servers and the other don't. Is that how that would work?
yeah, you'd have to have a dedicated ioGuardian, but what we recommend to our customers is, if you are going to replicate from site A to site B or C or D or E, just turn on the ioGuardian feature. It's going to save you more than it's going to hurt you.
Yeah.
There's literally zero reason to turn it off.
And I think you just answered the next question, but let's go ahead and address it. How long can I retain data on the ioGuardian server?
How much storage do you have?
Yeah.
The way you calculate that is, let's just say you're holding on to your daily snapshots for a month. You need to calculate, what is my change rate per day? How much unique data am I writing each day? And then you multiply that out. And that's your worst case scenario of, now if you write a terabyte a day, you need to be able to store 30 terabytes of additional data. So you need 30 terabytes more of capacity just to hold on to that data. But it completely depends on what your workloads are doing. And, there's an easy calculator way to figure it out.
And because of our deduplication, that would have to be a terabyte of net new data a day.
Yeah,
right?
I'm saying net new data, yes.
Yeah. Okay.
Yeah, you can write 10 terabytes in a day, but in reality, you only store 100 gigabytes, just depending on what the nature of the data is.
Okay, great. Paul, thanks for showing us all that. We wanted to keep it short today. We sort of accomplished that mission. I appreciate all the questions. If you have any additional questions, just reach out to us, and you all should have gotten probably emails from me. So those should all be, you can certainly reach out to me there. If you want to see the product and have myself or Paul or one of our engineers take you through a detailed deep dive of all the capabilities of the product, go ahead and let us know there, and we'll go ahead and answer them for you. For now, though, Paul, thanks for helping me out today.
Anytime. Appreciate it.
Thanks everybody for joining us today. Have a great day.
Bye.